right, let's get started. Okay, so PS5 is due tomorrow or Friday, depending on whether you use a late day. And then PS6 will come out and be due next week, and then there's fall break, which is good. Any questions or problems about anything? Any questions about the problem set? Yes?
Do we have to name our tests anything special for them to pass the validation?
No. Okay, so I asked, do you have to name the test anything special? No. No special name required. Yeah?
How many tests are you looking for? Is there a certain number or just go through everything we can?
Okay, so I'm not looking for any specific number of tests. The way the tests are graded is we just run your tests, and first of all, we make sure that when we run your test against a correct implementation, that all the tests pass. So if you take your test and submit them to Gradescope and you fail all 10 of my tests, what does that mean? Yep. Well, that'd be a 0 on the test part, but why would you? Okay, let me put it this way. If you take the 4 tests that I gave you initially and submit them to Gradescope, you'll pass 3 of the 10 tests. And what that means is that my 4 tests, when run against a correct implementation, all 4 tests passed, which you want to see, but only in 3 out of the 10 incorrect implementations was it able to diagnose a problem. So I have 10 incorrect implementations, 1 for each test case. And ideally, you would be able to detect each of them as incorrect. The tests I give you only work 3 times for 3 of the 10 cases. So you just need to add enough test cases so you can find the problem. But if you add an incorrect test case, one that fails when run against a correct implementation, you'll fail all 10 test cases. So I suggest you add the test cases slowly. Add one that you like, submit to Gradescope, and if all of a sudden you're failing all 10 of my tests, then the test you just added was bad. It's failing when it shouldn't. Yeah?
Do your test cases consider all of the possibilities of errors, or in terms of your PS5A?
Oh, okay, so now we're talking, so I was talking about PS5C just then. Okay. Okay, so he's asking, do my test cases for PS5A, so when you submit the 4 methods and I run test cases against them, does it consider all possibilities of errors? No, there are an infinite number of errors you could make. So, I just do the best I can to try to, you can certainly create something that doesn't work all the time in my test cases. You'll pass all the test cases. That shouldn't be your goal, but that's certainly possible. Yeah?
As far as approach, would you recommend, like when we do things like this, that we try to get the method to pass your test first, and then if it does that, then go ahead and supply additional test cases? Or would you recommend starting with extra tests?
Okay, so the question is, when should you write these extra test cases? Before or after you've implemented the methods being tested? My recommendation is that you write them in advance. Then you've got them to help you when you're implementing the code. I mean, doesn't it feel, okay, I only gave you a few test cases this time and asked you to write others. Wouldn't you have preferred that I provided all the test cases you need? Doesn't that give you a feeling of security when you're implementing, that you can tell whether the methods you're coding are right or wrong? If you like that feeling, write the test in advance, and then you'll have test cases when you're implementing 5A. Maybe you should start with 5C. Write the test cases first, especially since I'm giving you a way to debug your test cases by submitting to 5C. Yeah?
How do you consider the outcome of test cases? Because I know, to me there were some ambiguous definitions in the instructions, so at least to my perspective.
Okay, well, from my perspective, he's saying that he's sort of trying to relate the test cases to the fact that he finds the specifications ambiguous, so how do I test?
Yeah.
But to my eye, they're not ambiguous, so
Okay.
we need to come to a meeting of the minds here. If you think something's ambiguous, you need to ask about it, and I'll be happy to answer. Yeah?
On the PS5C auto grader,
Mhm.
when it tells you what's expected and what was the actual result, it gives you a number for what was the result. Is that the number of test cases that didn't pass?
Right, so if it said, so when, there are two kinds of error messages you'll get. One will say, if you fail all 10, it'll say, expected 0 but got 3. What that's telling you is that 3 of your test cases are bad. 3 of your test cases failed a correct implementation. If it says just assertion failed, that means that you didn't fail an incorrect implementation. Yeah.
So for the true substring, you know how there's a probability factor on that?
Mm-hmm.
What if you get an assertion error on that while running the test case? Is that fine?
So when you write a method that has to choose at random between some number of possibilities, the test case has to take that into consideration. So my test case, for example, for that method, it gives a string of length 5 and the method is asked to pick a substring of length 4 at random. It runs 1,000 times. It asks the method to make a choice. It counts how many times it picks each substring. Ideally, it would be 50-50. But it asserts that it's somewhere between 400 and 600 for each one. So it is possible, although unlikely, that the assertion would fail if you're extremely unlucky. I would run it again. I wouldn't think that you would fail it twice in a row. Yeah.
So could you repeat that, like the PS5C and when there's one, the auto grader give you assertion failed, what is that?
Yeah. So let me just write it up here. So if what you get is, if you get 10 error messages that all say that it expected, assertion failed, and it says expected 0, but got 2, let's say, and you see this 10 times repeated, once for each of my test cases, that means that 2 of your test cases, 2 of your cases fail for a correct implementation. Before I even try to run your test cases against an incorrect implementation, I make sure that they pass against a correct implementation. So this is the first thing that's checked. So if you see this kind of report 10 times, you know what's going wrong. 2 of your test cases are bad. On the other hand, if you see like 3 that say assertion failed, but doesn't give you a detail, it doesn't say expected 0 out of 2 or 0 out of 3, that means that your cases didn't fail for an incorrect implementation. Okay, so if you see 3 of these assertion fails, that means that 7 times your test cases did their job, 3 times they didn't diagnose the problem. So you either need more test cases or more assertions.
So if let's say we just have one assertion failed, that means there's less.
Yeah, if you see 1 assertion failed, it means that there's only 1 incorrect implementation that confounded you. Okay? Now people ask me, how do you know what test cases to add? So let me just give you some general guidelines. First of all, be sure that you check if it says that the method throws exceptions in certain circumstances. Be sure you test those circumstances. Create a test case that should cause the exception to be thrown and make sure the exception is thrown. Okay? If in the specification of the method you say, if you see this, if something is true, it does one thing, otherwise it does something else. Be sure that you have a test for the if and a test for the otherwise. And then another good thing to test is what are called corner cases. Corner cases are where there's a boundary between it does one thing on one side of the boundary, another thing on the other side of the boundary. So those ifs, an if otherwise is like a corner case. But what I'm thinking about is testing, like if it takes strings as parameter, test with empty strings. Make sure it behaves correctly when you give it an empty string. Sort of an extreme case, I guess, is better than corner case. If it takes non-negative integers, test with 0. Make sure it works with 0. None of the incorrect implementations are subtle bugs. They're all obvious bugs if you were to look at the code. So it's possible to find them. If you find yourself stuck on 9, you're getting one wrong, you can decide where you want to spend your time. If you're trying to get that 10th test case to pass on 5C, but you haven't started 5B yet, you're chasing 1 point and you're leaving 50 on the table. I would forget about that point and go after 5B first. And don't go fail a calculus test because you're trying to get 1 point on 5C. Manage your time. Any other questions? Yes? Okay, are you looking at a specific test case? Oh, yeah, that test case, yeah. What's your question about it? All right, let's see if I can find the... So this test case right here? Yeah. So the for loop is basically exists. You notice I is not used anywhere in the body. So the for loop is being used to call choose substring 1,000 times. So what I do is I call substring, and I expect to either get back A, B, C, D, or C, B, C, D, E, one of the two at random. So I count how many times I get one back, and I count how many times I get the other back. I would expect that to split 500, 500, but it never will be exactly that because we're talking about random numbers. So I just make sure that it does between 400 and 600 of each kind.
Is there any way like I can maybe change it to like for the next test case that I do, maybe to like 2,000 or something?
Oh yeah, if you want to base your test case on this, yeah, you could change it to 1 million. It'd just take longer to run. Be sure if you change it to 1 million, you change down here though. That's. Any other questions? Okay. Paranoid here. It's working. Okay. Now, in PS5a, when there's a point where I'm talking about the importance of using the 2-parameter index of method. And let me explain why that's important, because I get questions about that. So here is a way to search for a pattern in a string. Here's one possibility. You could just look at every index in the string. So you could say, you're looking for the pattern is, so you could take a substring of the first 2 characters in the string and try to compare that to is, and ask, are those 2 yellow characters is? And it would be no. Then we would look at HI, no. Then we look at IS, yes. So we found one match. And then we keep going from there, all through the string. What's the problem with that algorithm? Yeah.
Slow.
It's very slow. What makes it slow? Yeah? Yeah.
No, you're going one character at a time, so.
Right. You're doing lots of substring operations, and equals operations, and it's not too bad if the string's that short, but if it's got a million characters, like some of these books do, you're having to go through that entire string, computing all these substrings and all these equals, and that takes time. And that's to produce one letter of output. You have to repeat the same process for the next letter of output. So if it takes half a second to do this process through the whole string, the text of a book, then produce 100 characters is going to take 50 seconds. That's pretty slow. So it's slow to examine an entire book. So what I'm encouraging you to do is to use the index of method that takes two parameters. And so to find the first match, you just say find where the pattern occurs, start at index 0 and look until you find the pattern. Okay? And what's it going to find, assuming the pattern is is? Okay. Yeah?
It's going to show that the first occurrence of it is at index 2.
Well, yeah, it'll find that one. And then what parameters do we use in index of to find the next match? Where do we tell it to begin? So it found is at index 2. So that index of call will returns 2. So we got to call index of again. What parameters do we use? Yeah. Say what? Right. So we would start looking at index 3. So index plus 1 is where you restart the search, and it'll search until it finds that match. It returns 5. Now we ask to find the pattern, but begin the search at index 6, and it'll find that one. And then we ask it to begin at index 16, and it doesn't find one. So it's still, index of still has to look through all the characters, but it's just way faster. It took them using a clever algorithm, and it's going to be way faster than any way you're going to invent. So that's why I ask you to use that version of index of. We'd be waiting forever to generate text from one of these real books. It really won't affect the test cases. The test cases use really short strings, but it will affect when you're just trying to play around with it. Okay, now in lab yesterday, you worked with the collection classes. So you've got arrays, or not arrays I should say, you've got lists, you've got sets, you've got maps. And of course those are generic types. So you need to put in angle brackets what kind of list you're talking about, list of integer or list of string. Now I've seen a number of students in my office this week and on Piazza that when they go to declare an array list of characters, they just say array list and leave off the characters part. And Java allows that. And what you're creating when you declare just array list with no angle bracket saying what things go on the list is you're declaring an array list of objects. And what that means is you can put anything into the list that you want. You could put a string into it, and then you can turn around and put an integer into it, and put a font into it, all in the same list. And you may say that sounds great, but the problem is when they come out of the list, they're also objects. And you have to stand on your head a little bit to turn it back to treat it as an integer or a string or a font or whatever. So if you're getting weird errors where it's saying you can't store an object in an int variable, make sure that you aren't taking the shortcut and leaving off you're saying array list instead of array list of character or array list of integer. So that's an aside to this slide. So suppose I want to know all the distinct words that follow immediately after a particular word in Pride and Prejudice. So I want to know all the words that come after Elizabeth, for example. What type of object should I use to hold the result? Yeah?
String.
Okay. How would I use a string to do that? So let's say there are 100 different words that come after Elizabeth. So your proposal's fine, but how would you use it to hold 100 words? Okay. Someone think of a way?
String builder.
We'll use a string builder, sure, but what would the result string look like? Okay, suppose you analyze the book and you find that the word the follows, the word says follows, the word is follows. Okay? Suppose you find those three words that follow Elizabeth in the book. And you want to give the result back as a string. What would be a way to do it? Yeah?
Could you just put like a space between each word?
Sure. You would say the, and then says, and then is. Okay? That's one way to do it. What would be another way to give the information back? Not using a string. What's another way you could do it? An array. Okay? And of course, with an array, you would just create an array that contained, an array of length 3, that contained the, says, is. But what's the drawback of an array? Someone's got to say it louder. People are answering, but I can't quite tell what you're saying.
Fixed size.
Right, it's a fixed size. So you have to know typically what you're going to do. You're not going to collect all the words and then add them into the array. You're going to add them to the array as you find the words. And we don't know how long to make the array to begin with. So that's a problem. So arrays may not work out for that reason. So we've looked at strings and arrays. What's a problem with using a string? Yeah?
Like if you wanted one of the words out of the middle, it would be sort of hard to get to it.
Yeah. It's not particularly easy to get the words out of the string. You either got to create a scanner and then you can go through in order. There's no random access to the middle word in the string. So it's just not a convenient way to, if all you want to do is print the words out, that's fine. But if you need to do more, to take words out, it's not particularly convenient. You could make it work, but it's not too convenient. So both these approaches have drawbacks. So what would be another approach, another way to report back the answer? Using a collection type, a generic type. Yeah?
Use a set.
Okay. So let's say a hash set of strings. Okay, and what's the advantage of that? Yeah?
There's no repetition.
Okay, so no repetition, which is, I didn't say that explicitly, but I want to know distinct words, I don't want duplicates. Right. So as you find words that follow Elizabeth, you just dump them in the set. And that takes care of duplicates for you. Now, there's also, what about if we used a list of, so another option would be use a list of strings. Let's say an array list of strings. Okay, what would be the drawback of using an array list of strings? Right, it would just contain duplicates. So if you don't want duplicates, use the set. If you do, use the list. Okay, there are hash sets and there are tree sets. Why would you choose one over the other? They both have the same methods. Yeah?
Tree sets organize the inputs you put in.
Well, he says tree sets organize the things you put in it, but how? How do they organize them? I don't know if I expect you to know this or not. I don't know if I've told you or if you've read about it, but it's a good thing to know. Yeah?
According to the labs, is it like in the sorted order?
Right. Tree set, when you take things, when you iterate through a tree set, the things come out in sorted order. In a hash set, they just come out jumbled. So if you care about the order in which things come out when you iterate through the set, then you want to use a tree set. On the other hand, hash sets are faster. It's not like tree sets are slow, but hash sets are even faster. Okay, so that's good. So I say set of string there. That would either be hash set or tree set. Now, suppose that for each word that follows immediately after Elizabeth, I want to know how many times it does so. So I don't want to just know that the and said and it follows Elizabeth. I want to know that the follows one time and is follows 50 times and so on. That's what I want. That's the answer I want to get out of it. So what kind of data structure would I want to use to store that information? Okay, you're suggesting an array list, so let's go back to the drawing board here. And so my array list of what? What do I put in the angle brackets? String? But where does the count go? The count's an integer. So I want to know that the occurs once and is occurs 50 times. So I've got to be able to store the string and the number that goes with the string. So a list isn't particularly useful for that because it's either got to be an array list of strings or an array list of integers. I need a mixture. Okay, so it won't work too well for that reason. So what do I need to use? Yeah? Okay, use a map. Okay, so for that we'll just pick, let's say, tree map. And it would be a tree map. It would be a map that maps strings to integers. So each thing in the set, the keys would be the words, the values would be the number of times they occur. So if you want to think of the tree map as being this cloud here, then the would have a value of 1 in the map, and is would have a value of 50 in the map, and so on. Now, once you've created this thing, you can look up by key. So there's a method, get, where you say, okay, give me the value of is for this tree set, for this tree map, and it would return 50. Or give me the value associated with the, it would say 1. So looking things up in a map is like looking up things in the dictionary. If you know the word, it's easy to find the definition because they're alphabetized, and then you get the definition, which is the value. So a dictionary would be a tree map of word, comma, definition, if you will. Okay? So what we need is some sort of map that maps strings to integers. So the first step in learning to use the collection classes is to learn to answer questions like this. What type of collection do I need? So it's not enough just to know what methods there are. It's to be able to look at a problem and realize, okay, I need some data structure. Sort of a new word I'm using here, but these are all examples of data structures. Some way of organizing the data that's being computed by a method. Okay, now I want something else. For every word in Pride and Prejudice, I want to have a set of all the words that come immediately after it. So for every different word, so there might be 3,000 different words in Pride and Prejudice. I want to know what words can follow immediately after it in the book. So maybe the word Elizabeth can be followed by says and is and was. So I would want Elizabeth be associated with a set containing those 3 words. And so on for every word in the book. I want to know, for every word I want to know the set of words that follow that. So what kind of data structure are we talking about there? Yeah? Okay, so when I keep saying the set of all words, we need a set of strings for that. So every word will be associated with a set of strings. Okay, how do we do the association? A hash map or a tree map. And what would be, so it's a generic type, so if it's a tree map, let's say, I'll make it a hash map just for variety's sake. So we've got a hash map, angle bracket. What goes in the angle brackets? What's the type of the key? String, because we're mapping words. So you look up by, the key is what you look up by. So we look up by the word, and what we get back is what? Some sort of set of strings. So maybe we get back a hash set. So you see how these compose. So we could write a method that returned a hash map where the key type is string and where the value type is hash set of string. And that way, if you go, let's say our map is called M. If we go m.get of Elizabeth, what will we get back? What type of thing would we get back if we look up Elizabeth on the hash map? On this hash map? Yeah. Yeah, the hash set of strings of all the words that follow Elizabeth in the book. Yeah.
So why wouldn't we use a tree map?
We could use a tree map. It just depends. The difference between a hash set and a hash map is the same thing as the difference between a tree map and a tree set. I'm sorry. Anyway, we start over. Hash set versus tree set. The difference is the same as hash map versus tree map. It's a question of speed for the hash ones versus sorted order for the tree ones. So you pay a little extra cost and time to keep them in sorted order. It just depends whether it matters or not. Okay? So there's, after a while you get pretty good at playing this game. And I'm going to come back to this because I want to go and we've designed these methods. I've got to find the right place here. So here I have a main method that that calls this method problem 1. So problem 1 was that first problem that we looked at, problem 2 and problem 3. So let's look at problem 1 here. So that was, I've already forgotten what it was. Oh, it finds all the words that follow Elizabeth. And we decided we wanted to return, in this case I'm returning a hash set of strings. So I'm given a bunch of words, and I've got Elizabeth just baked into the code here. I want to return a set of all the words that follow Elizabeth. In the book. And I want to show you the starting point, and I'm going to let you have at it. What I do is I create an empty hash set here. So look at that. I'm declaring hash set of words, and then I'm initializing it to be an empty hash set. And I have two variables, word 1 and word 2. And this is an enhanced for loop, so I'm just iterating through all the words and all words. And then I've got this. If word 1 is Elizabeth, I step up and I take notice. If word 1 is not Elizabeth, I don't care. Every time I see Elizabeth, though, I'm going to pay attention. But what's going on here at the bottom of the loop? This is kind of an odd loop. Yeah.
It's just saying after you store the value of Elizabeth, it'll make that word now as the word you don't care, so you just keep going on.
Okay. So how would you characterize at any given point in the loop? Let's say at the beginning of the loop each time. What is in word 1 and what is in word 2? Well, I'll tell you what word 2 is. Word 2 is the current word we're looking at. Word 2 is the last word that we pulled out of that list. What's word 1? Word 2 is the most recent word we got out. What's word 1 going to be? The previous word. So a better name would be to call word 1 let's call this previous word. And let's call word 2 current word. So that's just a little coding trick that once you see a few times, you remember it and use it. So we always know the current word, and then we know the previous word. And we're saying here, if the previous word is Elizabeth, then there's something we want to do. So I want you to take a minute, figure out what statement do I put there so that I collect the set of all words that follows Elizabeth in the book. So if the previous word was Elizabeth, what do I do? Try to figure it out. I have visited classes and sat in the class while professors did what I'm doing, and I'm always shocked at what goes on. sitting with people, and as soon as the task is given, they start gossiping about stuff. But anyway, try to think about this. Figure out what needs to go there where I've highlighted. Okay, what do we want to do? You don't have to tell me code. What is it? When we notice that the previous word was Elizabeth, what do? Add the current word to the set we're building. Okay, that's easy enough. Now, how do you do it? Well, the set's called all words. So the question is, what's the method for adding something to a set? Well, it actually shows you add is the very first one. So we're lucky. And what are we adding to the set? Current word. And that's all it takes. So now if we run the program, we can see. So you remember yeah, got a question?
Shouldn't that be words to add, because all words is the
Oh, no, you're right. Thank you very much. So this was adding to the list of words. I want to add to the set I'm building. Same method though. Thank you. So if I run this, these are all the words that follow after Elizabeth, all converted to lowercase. And I souped up the code to take away the punctuation and stuff, most of it anyway. So, you know, it's interesting that the word Lizzie follows Elizabeth. Okay? There we go. So any questions I could answer about that? So if you had to say this loop was an accumulation loop, a searching loop, an optimization loop, what would you say? It's an accumulation loop, but it has an if in it, so that's kind of unusual. It has that trick with the current word and previous word. So it's been modified almost beyond recognition. The standard patterns don't work in every situation. Okay, now let's try problem 2. So here, I want to get back the set of all words. Is that what this one was? The set of all words that can follow Elizabeth. That's not right. Okay, it's how many times each word can follow Elizabeth, right? Yeah, we get back the hash map of string and integer. So this is set up again the same way. We've got current word and previous word, although I'm calling them word 1 and word 2 again. So when we see Elizabeth comes along, we are going to look and see if our hash map up here, that's our ultimate answer. It's going to map words to the number of times they occur after Elizabeth. If word 2 is already in the set, we do one thing. If it's not, we do another. Okay? I want you to think about that for a second. What do we do? What's the difference between finding a word that's not already in the hash map and finding a word that is in the hash map? Okay? Actually, I'll come back to you later. Let's just do a picture first before you're writing any code. So I'm trying to build some sort of hash map. So suppose I go along and I find that is a word that follows Elizabeth. What am I going to do with it? That's the first word we find that follows Elizabeth. Remember, we're trying to keep track of how many times each word that follows Elizabeth occurs. So what would I do? One of you, I don't know which.
Well, if it's, this is when it's not already in the hash map, right?
Right, so currently the map is empty.
Okay. Then you have to put it into the hash map and set its initial integer value to 0.
Right, so we have to add it to the hash map and give it and map it to 1 because it's only occurred once. Okay? Now, let's suppose we find another word that follows Elizabeth and it's had. What will we do with it? Same thing. We'll stick it in the set and map it to 1. Now we see is again. It's already in there. What do we do? Say what? So what we have to do is we say, oh, it's already in there. We have to look up is and find out what number it maps to. We get the 1 out. We increment that. That gives us a 2. And then we store it back in on top of that. So we change is so it maps to 2. That's why you got to do different things. First time you encounter the word, you just store it with a count of 1. Every other time, you store it. You don't store it. You look it up, get the current count, add 1 to it, and store the count back in. So that's what we got turned to code, these two cases. One thing you do with first time you see a word, and then things you do subsequent times you see a word. Let's look at the code now. So, given what I just told you, think about what code we stick right there. So we have found a word, namely word 2, that follows Elizabeth. What is it we want to do with it in terms of code? Okay, we need to add it to the hash map. Well, that's word counts. Oops. So we got to change word counts some. What is going on here? I'm in some weird mode. Whatever it has to do with this thing here. Okay, now we're back. So the hash map is called word counts. And what method are we going to do? We got to add the word. Anyone know what the method is called?
Put.
It's called put. And put expects the key, and I don't know why it wants to call it compute, but I've noticed Eclipse doing this recently is making bad suggestions. Okay, so what's the key going to be? It's going to be a string, so it's going to be word 2. And what's the value going to be? 1. Great, that's exactly what we did in the picture. We put the word into the hash map and we call it 1. Okay? What do we do if it's not the first time? What would be wrong with just doing this? If we do that, it's never going to be anything but 1 stored as the value. What do we want to store as the value? The current value plus 1. Well, that's good. Current value. But what is the current value of that word in the set? How would you get that out? Yeah.
Word counts dot get.
Right. So it's word counts dot get of word 2. So what we're doing, if we work from the inside out, is we're getting the current count of word 2. We're adding 1 to it because there's 1 more now. And then we put that as the new value of word 2 into our map. So now when we run it, silently occurs 2 times. Had occurs 38. Blushed only once. That's. I don't know what the most interesting to know what the most frequent one was, but anyway, We pull that out with not much trouble. Yeah.
If this is a tree map, would we get to know where the first,
Okay, let's change it. So he's asking what happens if we use tree map. So I'm going to change this to tree map. And I need to import it because I didn't do that before. And now let's run it. So what do you expect to be different about the output? It'll be alphabetical. It'll be in key order. Wait, I got a problem somewhere. Oh, I've also got to return the... Okay, now I'll run it. And you see it just comes out in sorted order, which probably what we want in this case anyway. Yeah?
Is there a way to make it go in order of like highest frequency of words?
So in other words, sorted by the value. So we see like the most common word first and then so on. There's a way, but we're not going to, not with this kind of tree map. We'd have to do something different. So let's talk about that problem. So we're looking at this and we say, wow, it's hard to search through here and find out which word occurs most frequently after Elizabeth. So we need a different data structure to tell us. What we need now is a data structure that maps frequency counts to the set of words that have that frequency count. Okay? So let's go think about that. What would that data structure look like? Let's see. We would like 1 to map to the set of all words that occur exactly once after Elizabeth. And we would like 2 to map to the set of all words that occur twice after Elizabeth. And 50 to map to the set of all words that occur 50 times after Elizabeth. What kind of data structure would that be? Is it still a map?
Yeah.
So it's some sort of map. We'll say tree map. Okay. Tree map of what? Integer's the key now. And what's the value? What does each integer map to? Not a string. A set of strings. So maybe a tree set of string. That's the data structure you need to build. So we could write a method that takes the data structure we previously created and convert it into this data structure. And then we would get, it would be easier to read the data out. But let's take a break before we think about doing that. So we'll take a break and then I'll try to decide if there's time to do that. Okay. All right, since you asked, I spent the break writing some code. So I've set up this method here. I called it problem 4 because it's I had three other problems illustrated. It takes as its parameter the list of all words, and it returns that map we talked about that'll map an integer to a set of strings. The idea being that it'll map 1 to the set of all words that occur exactly one time after Elizabeth in Pride and Prejudice, 2 to the words that occur twice, and so on. And first thing I do is I call that problem 2 method we just wrote. And so I get this data structure back, the one that maps words to numbers. So we'll call problem 2 to at least map words to numbers, which is the first step. Okay? It's nice that we have that method already written, because it'd be a pain to write it again, so we just use it. Then this is the type of thing we want to return, a map from integers to sets. So I create an empty one of them, and when we're all done, we're going to return it. So essentially, we're going to have to rearrange this thing, which maps strings to integers, into one that maps integers to sets of strings to get our answer. And I started this loop here that, what do you suppose that is? Word counts.keyset. So word counts is what's returned by problem 2. So word counts is this thing down here. What do you suppose word counts.keyset is? Yeah?
Returns the set of all keys.
Okay, so it's a set of all keys that occur in word counts. So it would be a set that contains accepted, added, admired, affected, after, afterwards, again, agitated, and so on. In other words, it's a set of all words that follows after Elizabeth. So it just finds the keys in this here. So we're going to look at each key one at a time. Now, what is it we have to do with each key? Suppose we come along and we see, accepted maps to 1. What do we do with that information? In fact, I'm going to do count equals I know I'm going to need this, so I just suppose the first thing I do is I've got a word and I look up how many times it occurs from down here. So if I look up admired, I'll get back 1. If I look up after, I'll get back 3. Okay? Somehow, though, we got to take the word and the count and use it to build this other map that maps counts to sets of words. So what do you think? What should we do the very first time we find a word? We got to put it in there. So how would you add? So our thing is called counted words. So we need to do a put operation. Oh, how does it do that? Hate that. Okay. What's the key going to be? So let's say we've just found accepted is our word. We're iterating through the words down here at the bottom. We've looked up accepted and find it occurs 1 time. So we put in that, 1 maps to some set. What set does it map to? No. So far, we know that accepted occurs once. So we're going to map 1. That's the first word we've seen that occurs once. So what should we map it to? Yeah? A set that has the word in it. Right. The set that has this word in it. So let's create one. We can say new, what kind of set? It's a tree set. New tree set of string. Okay, what have I just done? What's 1 mapped to? To the empty set. But we wanted to map it to not an empty set. It's got to be a set that contains word. So what I'm going to do now is I'm going to do counted words.get of 1. What will that be? If I do a get operation on counted words, what am I going to get back? I'm going to get back that very set I just created. And what should I do to that set? I should add word to it. Boom. Now that won't quite work, but it's a start. So what's wrong with this? What's going to happen if we run this? Okay?
Every time it, like, it'll make a new tree set every time instead of, like, adding more words.
Okay. Right? So let's work through this. We go through the loop once, and accepted is word. So word is accepted. We're going to put, well, actually, should I be putting 1 here? That's a mistake. Why do I not want, I don't want 1 there. What do I want? Count. So I wasn't even using count. So there are lots of things wrong with this. Okay, so we come along, we, word is accepted, count is 1. So we map 1 to an empty set. So far, so good. And then we get that empty set out and add a word to it. Okay, so now if we break right there and run the program, let's see what we get. Okay, so we're mapping 1 to the set containing accepted. Great. That's because we stopped after 1 word. Now, what happens if we let the loop run for 2 iterations? Okay, so I'm going to have to do a little count here. I'm going to do this, and I'm going to say if n is equal to 2, break. Okay? Now, you remember the first 2 words each had a count of 1. So what would we want to see after 2 iterations? What should 1 map to after 2 iterations? It'd be a set that contains 2 words, accepted and whatever the next one was that I've now forgotten. Let's see what happens when we run it. Okay, we wanted to see 1 mapped to the set containing accepted and added, because they both occur once. But we've thrown away the accepted part. So that's no good. If we get rid of this rigmarole that breaks after and just let the thing run to completion, this is what we'll see. So 1 maps to your, 2 maps to which. So all the sets are of size 1. So there are lots of words that occur once. There are lots of words that occur twice. But we're only seeing the last one that the program found, not all of them. And by the way, it looks like was is the most common word in Pride and Prejudice. Okay? How can we get all the words? What's wrong with this loop up here? Yeah? Okay, we need to do something different. Yeah, we need an if. So yeah, we always need to do this. We always need to do this, but we don't want to always store an empty set back in. When do we want to store an empty set as the value of count? The first time you encounter that count. So how can we find out if this is the first time we've encountered the count? Yeah? Well, it's going to be if counted words. So counted words is our tree set. Let's do a get on the count and see what it maps to. Now, the first time we encounter this count right here, there'll be no mapping for count in the set, right? Who knows what is returned when there is no mapping for something? It's null. So if count is currently unmapped, in other words, if this is the first time we've encountered a word that occurs that many times, then, and only then, we want to add the empty set as the value. Then we fall through the if and we add the word to that set. Now what will happen though if the second time we encounter that count? We'll obtain the count, we'll skip the if because it won't return null here, it'll return something else. and what's going to happen here after we skip the if. Same thing as before. It's going to go in and get the pre-existing set and add a word to it. So the key thing was we only store the empty set the first time. Every other time we're just adding words to the existing set. So let's run that and see what happens. Okay, much better. We see that the words that occur once are all these words, which is a huge pile of them. Okay? Then the words that occur twice are like at, been, by, and so on. And on to the end, where was occurs 64 times. That doesn't seem right to me. Why, there's no word that occurs 14 times? Anyway, that's what it says. Okay, so some of these issues we talked about are subtle, and they take a while to get your mind around. But that's, then your next assignment will help you get your mind around it, because you'll be doing stuff with maps and sets and lists and such. And there's another example I want to show you, but before I do that, any questions I could answer about what I've done so far here? The very first step, you've got to understand, you've got to be able to visualize sets and maps and such. Okay? And there are actually some slides that I skipped. Let me show you. Okay, this example here is pretty much like what we just did. And so here's the picture. So this is our map. So this occurs once, test occurs once, is occurs twice, occurs twice. These are the keys. This is test This code is pretty much what we just wrote. So when we process the first word, let's say is, or that's what we're going to do. We're going to map 2 to a set containing Then when we encounter the is, it gets added to the existing set. Then when we count test, it gets added to a set that 1 maps to, and then this gets added to that set. So you've got to be able to visualize a map containing sets. It's also important to realize this picture is misleading. All objects don't contain other objects. Objects contain references to other objects. And so that's a more accurate picture. 2 maps to some set that's stored elsewhere in memory, and 1 maps to a set that's stored elsewhere in memory. And even that's misleading because strings are objects, so it's really more like that. But that gets too confusing, so let's not do it that way. But the important thing to realize is that when you go to this map and you say, give me out the value that 2 maps to, what you get back is not a copy of this set. What do you get back? So set is, say we go in and we look up 2 and we get back, what's the value of set now? How would you characterize the value of set? Yeah? Well, it's a reference to a set containing A and this. So the point is, if you went and if you think about this picture and I said, okay, you look up 2 and you get back the set, you might think, what happens is you get back a copy of the set. And that wouldn't work because if you modified the copy, it wouldn't modify the original. But since the picture is really this, when you ask for the value of 2, you get back a reference to the set that 2 refers to. So this black arrow is a reference. That's why they're called reference types. So set, the variable set refers to this thing, and the 2, the key 2 maps to that thing, but it's the same thing. So if we say set.put to modify this, it's also going to be modified from the point of view of this key. It's also going to see the modified set. The set is shared between the 2 references. That's absolutely essential thing to understand about Java. Objects are shared. They're not copied. And the reason we don't have to worry about strings is because strings can't be modified. And so you can't tell the difference between strings being copied or shared. You can't modify them, so the difference doesn't matter. But the difference does matter with a mutable thing like a set. So just keep that in mind, that when you say have a variable that contains a set and you assign that set to another variable, those two variables refer to the same set in memory. It's not two copies. It's the same set. Okay. Didn't mean to do that. But let me get this back up. Okay, so here is another problem to think about. So I'm going to write a method that takes as parameter a table like that. So it's going to have rows and columns. And it's going to be organized kind of it's just going to be well, I'll show you how it's organized later, but it'll be a sequence of rows. So the first row is the header row. You got name, city, age, salary. Then you got John. Then the rest of these are values. So there's 5 names in the name column, 5 cities in the city column, 5 ages, 5 salaries. And then I want a method that'll do the following. It'll take one of these tables as a parameter. It'll take a header, the yellow header in this case, which is called the condition header. So in this case it's city. And it's going to take a value header, the purple one, which is salary. And it's going to take a value that can occur under in the condition column. In this case, SLC. So the parameters will be the table, the string city, the string salary, and the string SLC. And the job of the method is to find every salary that corresponds to an SLC and average them all together. So the deal is, okay, in the city column, SLC occurs 3 times. So it would take the 75,000, the 80,000, and the 0 and average them. Now, we could also do age. We could let age be the condition header and salary the value header. And then we could ask, what's the average salary of all 25-year-olds? Or we could say, what's the average city? It won't work here for city. We could ask, what's the average city of everyone that makes $70,000? But that wouldn't quite work. So the thing we're averaging needs to be a number. And the headers things have to be, the condition headers have to be, the values have to be strings. All right, so first of all, let's see if you understand what I'm after here. Table, we designate one column, 2 columns we care about. One is the condition, one is the value. And then we also get a value. And we find all rows under the condition that match the value that we passed in as a 4th parameter, and we average the corresponding things in that column. And the table can be as big as we want, as many columns, as many as rows. That's our job. Okay? So that's a little more complex than the things we've looked at before. Let's look at some code to do it. Okay. So here's the code that I have, the starting point that I have. So here's an example of the data. And we're going to represent a table as a string initially. So it's going to be a string containing everything in the row separated by tab characters with a new line at the end. So our string is going to be name tab, city tab, age tab, salary, new line. John tab, SLC tab, 25 tab, 75,000, new line. So just a string. And here's our method. Well, the method takes a scanner that's reading that string I just described. It contains the condition header, like city. It contains the value header, like salary, and the condition value, like SLC. And then it has to do its deal. So, let's see what I do. First thing I do is I grab the header row. So the first line out of the scanner should be the header row. And I want to find out in what column does the condition occur and in what column does the value occur. So we take that city, and we got to figure out which column, is it column 0, column 1, column 2, what column is headed by city, and what column is headed by salary. Is it column 3? Is it column 8? How can we do that? Okay, we know the answer isn't 0. So we've got the header row to work with, and we have the condition header that we're looking for. So this first thing, we got to find out which column of the header contains condition header and which column contains value header. How do you do that? Yeah?
Could you loop through the row and check each word to see if it matches the string?
Okay, we could somehow loop through the header row trying to look for tokens that match the condition header and do the same thing for value. Yeah, that's one way you could do it. Yeah?
Could you search the header row for the index of the condition header?
Well, you could search the header, you could use index of and find out where in the string it occurs, but that doesn't tell you what column it is. Because it could occur at character 50 and be column 3. It depends on how long the things are. So these are all good suggestions. But the point of this example is to tell you that you're faced with this problem. So we've sort of got this, the code looks pretty simple. We just first got to calculate the condition column and the value column. And your first temptation as a beginning programmer is to write some loops here. But what a more experienced programmer does is they realize, you know something, the problem of finding the condition column and the problem of finding the value column is really the same problem, right? In both of them, you're taking the header string and you're trying to figure out where some substring occurs in there. The inputs are different, but the problem is the same. And so the solution is not to try to complicate this code you've got. What is the solution? How can we keep the code simple and also respect the fact that it's really the same problem we're trying to solve twice? Yeah? Create a method. So I call this the principle of wishful thinking. We wish for a method. We say, wow, if we only had a method that could figure out what column something occurred in a header row, we would use it twice here and be done, right? So we would do something like this. We'll say find header column, and we would pass it, not the table, we pass it the header row, and we would pass it the condition header, and it would return to us. We wish what it would do is return to us the correct column number, and then we would do the same thing for value. We would use our wishful thinking, and we say, you know, I really wish this existed, and then I would just pass in the value header. And then we'd be off to the races. Okay? Unfortunately, those methods don't exist. That method doesn't exist. So what's the next step? Create it. And this is where I run into trouble trying to convince students that what they ought to do to solve this problem of writing a method is to write another method first. It's because you keep getting these homework assignments from me, and I say, okay, here's a list of methods to implement. So every week it's like, oh man, more methods I got to implement. And so you start to equate methods with work, and you say to yourself, I've got to write one method, why should I write 2 instead? Okay? But the answer is, once you get reasonably good at writing methods, rather than writing one really complicated method, write 2 simpler ones. They're easier to test, easier to understand. Furthermore, suppose eventually we're going to implement these methods and write some code. What would happen if we didn't make methods calls here? What would our code look like? There'd be a loop to compute condition column and a loop to compute value column, and the loops would be virtually identical. Anytime you find yourself writing one block of code and then another block of code, and they're essentially the same code, that's a red flag. It's saying you should have written a method, written it once, and called it twice, rather than just making your code more complicated. So what help does Eclipse give you to create this method that you just wished for? Right? I've shown you this before. Just it'll create the method for you. So I click on it, and it goes and it creates it for me down here. Now, I have to make sure it's like I want, so it's got the right name, it looks good. Probably I don't want to call this one condition header, I just want to call this header. Okay, what should I do next? What's the next step once I've got I've got a stub for the method that I need? JavaDoc. Thank you. When you write a method, always write JavaDoc. I'll let you off that with test cases. I hardly ever write JavaDoc for test cases. I just try to give a descriptive name for the method. But every other method, you always need to write JavaDoc. So I could write some JavaDoc for it. What would I do next? After I've written the JavaDoc? I could start implementing it, or you could write some test cases for it first, so that when you're done with it, you can test it. Because you'd really like to know that find header column works correctly before you go and try to implement conditional average. Because suppose you don't test find header column, and you go up here and start implementing this method. And that method, then it turns out this method doesn't work. Where is the error? Is it in conditional average, or is it in find header column? You don't know. So you want to test the pieces before you test the thing that uses the pieces. So eventually you have to write test cases, so might as well write them first. Then you implement. Well, I've already done that, except I called it something different. So there's our method. So I'm going to wipe this out. And I'm going to call it that up here instead. And I even have test cases written. So at this point, now we're ready to actually go and implement the method. I don't have time today, so we'll finish this next time. But I want to point out something before you get up and leave. So this is the end of week 6 of the semester. Yeah, so PS6 will come out. This is as far as the midterm goes through today. And I guess I'll add on, we've got to finish this example on Monday, so we'll finish the example, and that's part of the midterm. But through today, with that little extra plus PS6, that's the midterm. So just wanted you to know that.